Hello everyone. We are going to understand some binomial distribution diagrams in order to understand critical region questions. Let's say probability is 0.5 and probability can be less than 0.5 and probability can be more than 0.5. When probability is going to be 0.5, let's say the number of trials are 20, and then so the diagram, so for 0 and 20. The meaning of this 0 and 20 is for I'll take an example. Let's say probability that I get my train on time is 0.5. This 0 represents the probability that I get my train on time 0 times. The probability that I get my train on time 20 times. So that is the meaning of the 0 and 20. And it is going to be even because probability is 0.5. So this 10 times, out of 10 times, when it is 10, it is going to be the peak. And the graph is going to be like this. If it is less than 0.5, again, I'll take the same train example. Let's say probability that I get my train is 0. The probability that I get my train on time is 0.1. There are some areas in the world where always trains run late. Let's say probability in that area I get train on time is 0.1. Then probability that, let's say out of 30 days, probability that it won't get on time at all, my train don't get on time at all, and is going to be this. Probability that my train get only one time out of 30 times, probability that I get on time only 2 times. If you see, as the probability is very less, so out of 30 days, probability that I get my train on time is less. So on less number of days, I'm going to get my time on time because of this. That tells you that there are high chances that I don't get my time on time. There are very, very less likely chances that I get my time or my train on time more number of times. Similarly, if probability is higher, let's say you are in one of the best cities in the world, and then let's say probability is 0.9, I get my train on time. Almost, let's say if you take 0 to 30, almost most number of days I would get my time or my train on time. So probability that I don't get my train on time at all, like I don't get my train 0 number of times, is very small, isn't it? Because higher chances are there. Out of 30 days, probability that I get my train on time only one time is also very less likely. So probability that I get my train on time is more on more number of times is going to be more. And again, probability that I get my train on time all 30 days is going to be small. Every single day to get on time out of 30 days, it is going to be small. And this is how the diagrams are going to be. Whenever you see a smaller probability, you will have a big right tile because you have less chances to get most number of times successful. And the probability is higher, the big tile is going to be on the left hand side. Probability that you get failure is very, very less. And if you understand this, and if you understand critical regions, and this one particular method can solve almost all hypothesis testing questions. And the next one now. Actually, the first question, a single observation is taken. See, whatever the language they use, I look for my requirement, as in I look for what probability is given in the question, which is 0.35. And then I look for what is H naught. If there is some, they already gave us in this case. So P is equal to 0.35. And H1, P is greater than 0.35. And the test statistic, in this case, test statistic is not given. So whenever the test statistic is not given, that is a critical region question. And see, this one, don't worry about this one, because if test statistic is given, you write this. If you don't, if test statistic is not given, you don't write this at all. And most importantly, you can see that they directly asked you to find the critical region. That's the keyword. So whenever they ask you to find the critical region, you need to use this method. As we discussed before, this probability is less than 50. So somewhere it is going to be, the diagram would be like this. And number of trials 0 to 6. In the middle it is 3. Whenever you see greater than symbol in the question, you go to the right tile. See, if this is confusing, you can find both left and right tile. However, remember this, whenever it is greater than symbol, you go to the right tile. You go to the right tile and you mark significance level on that 5% probability. Let's say from here it is 5% probability. And now we will see for what value, from what value it started becoming less than 5%, meaning there are 6 observations, there are 6 number of trials. For what, starting from what number of trials, it became less than 5%. That's what we are going to find. So when you use the calculator, you go to menu, statistics, menu, statistics, and distribution, binomial, BCD. It should be in variable mode. We are going to find like what is this number, and until 6, the probability starting from this number and until 6. So until 6, so upper becomes 6. Number of trials are also 6. And probability is given 0.35. Now, this lower value, you would randomly see. This is 3. Right tile would be, so the percentage would be less after 3. Maybe let's say I'll start with 4. Let's say this 4. And I'm doing this to find if that value is, if that starting from that value is less than 5%, because we started with 4. See, I got 11%. So I'll write it here. In the examination, you can write when x equal to 4. So, or you can write P of x equal to 4 is 11%. But I'm looking for the value when it becomes less than 5%. Now you may have a doubt that whether you need to increase the value or decrease the value. Pay attention again here. When you are checking the right tile, let's say we got 11% when x equal to 4. To get a smaller percent, you go right side. You go right side as in you increase the values. To get a smaller percent, this tells you the percentage is going to be smaller. And now, let's say lower value is 5 now. It is 2.2%. Now, when it is 5, I'm changing my color now. When it is 2.5, sorry, it is 2, when it is x equal to 5, when x equal to 5, it is 2.5%. So P of x equal to 5 is 2.5%. which is in the critical region, because we are checking for the value which is less than 5%. So this is in critical region. The critical region is any value starting from 5 until 6. In this case, only there are two values. So you would write critical region is x less than or equal to 6 and more than or equal to 5. I hope this is okay. And now you see, you go to the question, find the critical region for this test. As they're asking for critical region, we started with the right one. We also find the left one as well. So as it is given greater than, we always start with the right one, and we go for left side as well. If you go to the left hand side again, so again we choose critical region is 5 to 6. Critical region is 5 to 6. And now actual significance level of the test. The question is asking what is the actual significance level of the test. It is also called p-value. It is asking you what, starting from what value is in critical region. What is the starting probability which is in critical region, which was 2.5%. You write actual significance level P is p-value. Generally, it is called p-value is equal to, you got 2 point, sorry, it was 2.2%. So this should be 2 point. So 2.22 2.23% something. So this is the actual significant level. You can also write in decimal 0.022323179. You can write in decimal as well. This is how you do the critical region. I hope this is okay. And coming to the next one, this is an interesting one. If you see, probability. So we start writing, they gave us H naught and they gave us H1. H naught is 0. P equal to H naught, P equals to 0.25. H1, they set P is not equal to 0.25. And this is the catch here. In the examination, if they tell you that not equal to or different from 0.25, then it is two-tailed test. These are the key words. It was one-tailed test. The previous question was one-tailed test because they said greater than. If you see, if you see that it is different from probability, or if you see that not equal to, it is two-tailed test. If it is a two-tailed test, what happens is, I'm going to show that through the diagram. Better we always draw the diagram. 0.25, number of trials are 40, 0 to 40. The probability on it won't happen many number of times is bigger because 0.25, and this is going to be the diagram. And now somewhere here this is going to be 20. Again, they gave 2% level of significance. Whenever it is two-tailed test, you make it half and you give one, you say 1%, you mark 1% on the right tile, and you mark again 1%, 1% on the left tile. And you would see on the left side, so you can start with left tile now. We will do one tile at a time, left tile. On the left tile, you would see starting from 0, this is 0, starting from 0 until what value it is less than 1%. Starting from 0, you are seeing starting from 0 until what value it is less than 1%. You go to the calculator again. You have So the already we know that the lower value is 0 because starting from 0, we don't know the upper value, and number of trials are given 40. Sorry, number of trials are given 40, and now probability is given 0.25, and upper tile maybe randomly I'll take 3. It is when x equal to 3, p of x equal to 3 is 0.0046957. Yes, it is well less than 1% because it is 0.04%. But still, we will see if we increase the values, if you need to see the last value, which is less than 1%. So I would go. So now some of you may be confused that whether you need to decrease the values or increase the values. You need to increase the values because we are looking for higher probability. We are looking to go until 1%. This is just 0.04%. We are looking to go for bigger probability. If you see, you'll get bigger probability as you go right side. So meaning I'll check with 4. I'll check with 4. Hmm. So 0 to 4, 1.6%. But the catch is here, probably this is 0.016042223, which is more than 1%. So 4 is going to be somewhere here. We don't need that value. The last value which was in critical region was 3. So again, I'll change my color. So to label what point is in critical region, you can see that x equal to 3. When x equal to 3, this is in critical region. So the critical region is on the left tile, which is 0 to 3. You need to show this in the examination. This is greater than 1% and this is less than 1%. And the right tile now. When you go to the right tile, so we have done one question already on right tile. Still we'll complete this question. On the right tile, so I'm writing right tile. So again, when it's right tile, you know that we will see starting from what value until 40 is less than 1%. So we know that we are checking until 40, so it becomes 40. And logically, if you see, you need to take somewhere definitely bigger than 20. And maybe I'll take lower value as 21, which is small, 0.00 something. You can see that which is 0.00 something, but I need a value which is closer to 1%, meaning I need some bigger probability here. I'm getting very small probability. I need a bigger probability. For example, let's say this is this if you convert that into percentage, that is not even closer to 1%. I need to increase the probability, so I go to the left side. So as I go to the left side, I can get the bigger probability. To go the left side, as in, we will change this value, the starting value. Maybe I'll take 19. So I'll write P of x equal to 19 is equal to 0.0017 and so on. Still, this is smaller. I'll change this value. I need bigger probability. I'll check with 18. 18 is a bit better. So P of x equal to 18, I'm writing it. P of x equal to 18 is equal to 0.004. Still, I need bigger value. Maybe I'll check with 16. 16 became 2.6%. P of 16, P of x equal to 16 is 2.6%, but I need a value which is less than 1%. So less than 1%, I need to decrease the probability. You get the probability, the probability will get decreased on the right side as you increase the value. So maybe I'll take 17 here, which is 1.1. So P of x equal to 17. P of x equal to 17 is 1.1%. So we would take this P of x equal to 18 because that is the first value which is less than 1%. So with that the value, so when it is 18, which is 0.000046515. So you know that P of x equal to 18 is in this critical region. So starting from here, it is in critical region. So x equal to 18. So starting from x equal to 18, 18 to 40, 18 to 40, that is in critical region on the right tile. That's how you find the critical regions on the left tile and right tile. Write down the actual significance of the level of the test. The second part, actual significance level. So actual significance level is you take the value when x equal to 3. This is the value. This is the probability. This is the first probability in the closest to the 1%. This is the value. You take this value. In simple words, you take this value, whatever the value you got for x equal to 3, because it is the value in critical region. And then you take this value, the second value, you add both of them. So 0.004695 and 0.004615. So which is 12, 7, 14, 13, 9. So this is actual significance level. This is the answer to this question. I hope this is okay. Please go through again and again if you need to understand it clearly. And you can also email me if you still haven't understood this one.